All right, hopefully you guys can hear me all. So hello and welcome back to GoLab 2020 virtually this year. We have a really great Ask Me Anything portion with the Go team, and we have Miriah Peterson and Natalie Pistunovich, who will be the moderators of this Ask Me Anything session with some members of the Go team, including Carmen, Katie, Ian, and Austin. So welcome you all. Thanks for coming, and there will be plenty of questions. This is a great opportunity to ask questions about what's been happening recently with the language, which is a lot actually, and what will happen in the future with Go. So we already have questions submitted and upvoted by all of you, but of course they'll obviously accept more questions if there will be enough time. So thank you all, and I hope you enjoy. Thank you, Miriah and Natalie, for being here. Appreciate it.
Thank you so much, Latara.
Sure.
Welcome, everyone. Miriah and me are super excited.
Crazy excited. You can see it on our faces.
Yeah. We are broadcasting to you from Berlin, and
I'm in Utah in the United States.
Halfway
around the world.
What is the time over there?
It is 8:30 a.m.
Nice. Are you a morning person?
No. I am the opposite of a morning person, and I'm also not a nighttime person. So.
Well, here it's 4:30 p.m. I guess Italy and Germany are on the same time zone.
Well, that's nice.
Yeah. So we have a great team today, and we also have a hashtag for Twitter, and we have a Twitter handle. The Twitter handle of the conference is GoLab_conf, and the hashtag for this conference this year is GoLab 2020. And well, for the Go team, it's Go team. So we would love to welcome the Go team on board. Here's
Hello.
Austin, Carmen, Katie.
Awesome.
Ian's also here.
And Ian. Oh.
Ian's further down the list.
There we go.
Hello. Welcome, everyone.
So excited to have you here.
Excited to be here.
Yeah, why don't we go ahead? You can take a few minutes, each of you, go ahead and introduce yourselves, and why don't we just throw something fun in there, like a hobby you like to do when you're not working on the world's best programming language. So we'll start with you, Austin. You're in Cambridge, Massachusetts, is that correct?
That's right.
Okay, not close to me, guys. Go ahead.
Not particularly, although I did grow up in Utah, so.
Awesome.
Yeah, so I'm Austin Clements. I am the technical lead on the Go Runtime and compiler. And in terms of a fun thing, well, I just told you that I grew up in Utah, but random fun thing is that every morning I like to start my day with matcha latte. So I've been making matcha lattes for something like 8 years now. I've been slowly perfecting my technique over the years.
Did they start out gross and get better, or are we just like, they just go from good to best?
Most of it went from good to best. I did discover a few mistakes at the beginning of this process, which were definitely on the wrong side of good, but.
Okay, and if I'm to understand correctly, you work on the compiler and runtime team?
That's right.
That's scary to me. Crazy scary to me. But I'm glad you're in charge of it and not me.
It's a lot of fun, but we have to be very careful because everything runs on top of this.
For sure, for sure. Okay, Katie, let's go to you. Looks like you run on the security team. Am I mistaken in thinking you're out of New York, or is that?
I am.
Okay, go ahead.
I really didn't have like any excuse to not finishing my breakfast because people from way earlier time zones were here. So, I'm in New York City.
Cool.
For the Europeans among us, what is the time in New York right now?
It's 10:30 a.m.
Okay, cool. Well, it's still okay not to finish your breakfast at 10:30, I guess. In work from home days, you're good.
Agreed. Okay, let's go to your fun fact that's not related to your programming language development time.
Well, I wish I could say that I made matcha lattes every morning because that sounds really wonderful. But things that I've been doing in my free time outside of Go, I think at least like during the pandemic, there's not a whole lot to do in New York City because you can't go to shows or restaurants or bars as often. And so I feel like I've just been mostly playing video games because that's been a fun pastime to kind of hang out with people. And, I haven't played Among Us yet, but I really want to.
That's a good game.
Yeah.
Are you playing that guitar? Are you playing that guitar behind you?
Oh, and I also have a guitar, but I've been neglecting it really badly in the last couple months. Yeah.
That's a perfect timing to neglect such a hobby. When you're alone at home. Cool.
Okay. Ian, you're next on my list. I believe you're the most tenured on the team that we have here today. I have no idea where you're based out of, but we'll turn the time over to you.
I'm here in Berkeley, California, where it's 7:30 in the morning. I've been on the Go team since 2008, since before we did the open source release. I've been working on it all this time. I work on a lot of different things, but mostly on compiler and tools and other low-level stuff. I guess my fun fact will be that we have ducks, my family. We have 5 ducks now who live out in our front yard, so they're a big attraction. Kids come walking past and to look at the ducks.
Did you buy the ducks, or did they adopt you as a house?
They're domestic ducks. Yeah,
Okay.
we bought them when they were just 1 day old, and we don't have a big front yard, but big enough for them, and they have a tiny little pond.
That's awesome.
And they're very cute.
Is that a common pet to have?
I go with no, it's not a common pet.
That's
But
so interesting.
we're not the only ducks in Berkeley, California, so there are others.
Cool. I never knew anyone who has ducks. That's so interesting.
Awesome. Okay, last but not least, we have Carmen.
Hi.
Go ahead. You're out of New York as well, right?
I just moved.
Oh, you're not?
Yeah, I'm now in Ann Arbor, Michigan, so near Detroit.
That's cold.
Yeah, I
It's
know.
a good place to be. I mean, it's a college
I don't want to
town.
think about
It's
it.
great, but man, that's a cold place. Sweater weather.
It is. It is. I don't want to think about it come winter, but we'll take it one day at a time. So about me, I work with the Go team starting last year and was heavily active in the community before that. I work with what I would broadly call the ecosystem. So really trying to understand everybody's needs and help be a facilitator of that between whether it's companies, projects, individual meetups, developers, and the Go engineering teams throughout the United States. So a fun fact about me, I was an infrastructure engineer before joining Google, and I have a great collection. I travel all over the world to take pictures of sewer plates as a reminder of infrastructure. I have many that contain the Florence Giglio, or lily, symbol of Florence, Italy, and that's one of my favorites. And I only wish that I could have been taking pictures of those in person this year, but hopefully soon.
I agree. I feel gypped on a trip to Florence, so we'll have to try again for a non-pandemic conference.
Yeah.
Cool. Natalie, do you think we should introduce ourselves as well with a fun fact?
I think that's a great idea.
Okay. Do you want to go first or me?
You go ahead.
Okay. Cool beans. Well, I'm Miriah. I am out of Utah in the United States. Fun fact about me. I'm speaking tomorrow. That doesn't count. That's just a shameless plug for my talk tomorrow. Yeah, I have 2 dogs, and they are my life. One is a puppy that I got due to the pandemic, and so I've had a lot of fun with her. And we spend a lot of time going to dog parks and going on walks, and I spoil them religiously. And yeah, I identify as a proud dog mom.
I'll pick up the fun fact, the furry one. So I have a cat, and her name is Java, and she is named like that because of the coffee beans, because her fur color is chocolate brown. But it makes a lot of the tweets really funny.
As long as it's not after the programming language, I have not lost any respect.
It's also named after the same coffee beans, so basically they're siblings, the cat and the programming language. Yeah, so how did everyone get into programming?
I can start that one. Mine's kind of silly. I was, my dad, he kind of left his computer PhD. He came to this country to study what was then electrical engineering when there was like still cathode rays back in the 50s, and then left ultimately to go do something else. But he always remained heavily fixed in Unix environments, and so I didn't know anything else. And he worked for a university, and I remember going as a little kid. It was an IBM PC that was Unix, but I don't remember the model. And I just remember having to access the chess game that was like 8-bit and the piano game that was 8-bit through the command line. I remember that. But my first programming language was BASIC. And I remember just, telling stories about how everything starts with 10 and like all those puns. And increasingly when I try to tell a basic joke, no one really gets it. So that's my story. And I think I was still in elementary or maybe beginning that 6th grade when I took an official basic course, but that's what I remember.
I can follow on to that. So I also started with BASIC. I think it was for my 7th birthday, I got a little kid's chemistry book. And in the back of it, it had this program listing written in BASIC for like something like classified metals or something like that. And I went up to my dad and I'm like, Dad, can you put this into the computer? And he did. And conveniently, he was also a software engineer, so he actually knew what was going on. And then I started asking him all these questions about like, oh, what does this do? Like, how does this work? And then he's like, just go read a book. But that was how I got started, out of the back of a chemistry book.
Yeah, my first language was also BASIC. I think it was pretty common back then. I was fortunate in that my high school had a computer, which at the time, I'm a little bit older. At the time, it was not so common. And we even were able to access the computer before I got to high school from our elementary school. But I always kind of wanted to be a programmer. I was always fascinated by computers. Even before we actually had a computer, I was interested in them. So my first actual computer that I could use myself was a TRS-80. And I've just gone from there.
Well, I guess I could go next. I'm actually glad I'm going last for any of you who are experiencing imposter syndrome because you didn't start coding as a child.
Me.
And I did not start with BASIC. I think my first programming language was C++, and that was because that was the language that my senior year in high school class, it was taught by a math teacher, was taught. So I actually got into computer science because I like math. I talked about this actually a bit in a recent GoTime podcast episode, but I just really loved math. And I had to take computer science classes as part of the math module at my college. And then I found that I wasn't having as much fun in math, and it wasn't social enough, and I wasn't getting to know people. And so I ended up working in computer science kind of by a fluke, and by the fact that my father's also a software engineer. And so it just kind of fell into it. I was kind of almost dragged into it, like, well, okay, I guess I'll have fun doing this. And I didn't actually start learning Go until I was on the Go team. So I'm one of the few that learned it on the job, but I love it now. Much better than C++ from my experience. It's easier.
That's hard mode for your first language. Kudos.
Yeah.
No worries, Katie. I came from physics, so I think we followed the similar path to Go, and we have found the light. So yeah, Kay, before we jump into anything hard or crazy, do you guys have any fun hobbies that you like to do to take your mind off of your hard day jobs?
Baking, well, like a pandemic hobby would be baking. My waistline has thanked me for that. Yeah.
Yeah, I feel like sort of pandemic hobbies and
they all apply.
Hobbies are maybe
you have
two
a life
different
before
categories.
COVID.
Definitely one of my pandemic
TV.
hobbies. One of my pandemic hobbies, since I've been spending all of my time at home, has been getting into smart home automation. So like pre-pandemic, I think I had like maybe 2 lights that were on automation, and now like all the lights are, and figured out how to get the washer and dryer onto automation and the garage doors. And
Side question, do you use the Google home automation system, or are you doing it from scratch?
I'm actually mostly using Home Assistant, although
Okay.
it is tied into the Google Home, so I can still do voice commands and stuff. But it's all running off of
You can program
the
your own commands and all that fun jazz.
Yeah.
Cool.
I can agree with Carmen that I've also been enjoying baking and cooking, though I've like changed my diet quite a bit over the quarantine, because the beginning of quarantine was just like all the sweets that my body could consume. And then I realized that wasn't really gonna work out in the long term. So I had to kind of switch it up. And so I haven't been baking as much, but I have had to learn how to cook because of quarantine, because I live in New York City and nobody cooks in New York City, because you just eat at restaurants, because why would you cook? But everyone had to learn how to cook, or else I'd be ordering like Indian food and Chinese food takeout every day. So
That's what I do. I quit cooking with COVID, so
I respect that too. I think it's a completely reasonable thing to do. I just, thought that cooking would be a nice pastime.
more power to you.
I guess my non-programming hobby, other than, taking care of the ducks and the dog, is running. I ran pre-pandemic, and I'm still running, although now I'm running close to home. That's been the change.
Like marathon running? Do you do races, or are you just like to get out there?
I've run a few marathons, but I wouldn't say races. It's more like I start at the beginning and I finish at the end.
That's a race to me. If you finish it, it's a race.
Okay. Finish it.
Ian, I have a question for you. What is it like to work on the programming language? You're actually working on the thing that everyone else is using, literally the code. This is not the same as working on something or building something that is made with a language like some products.
It's not the same, but it's similar. It's not like it's terribly different. It's just as working on the programming language is sort of like working on a library, and that you need to focus on, what's going to be the clean API, what's going to be usable, what's going to be not confusing. I mean, for Go, I think, I mean, I wasn't there at the very beginning, and I think that, Ken, Rob, and Robert have really adopted a good approach to the language as they started developing it, which was, try writing programs and see what seems to be missing. Try things, and as you run into obstacles in your code, try to figure out if there's a way to change the language to make those obstacles go away, and really focus on keeping the language simple and keeping it orthogonal, which in language design means that there aren't sort of special cases. You want as much as possible for sort of each language construct to work the same way in conjunction with all other language constructs. You don't want to have some special rule that says like, oh, you can't have, this type can't be a struct field or something like that. Mm-hmm. And so it's been, working on the language itself, which I've been doing in trying to develop generics for the language, has been, with something as big as generics, it's hard. It's a constant struggle to try to fit it in smoothly with the language, to keep it simple, to try to understand what it is that people need, and how this can actually solve their problems without making things too complex. But as I say, these are things which I think any library designer should ideally be thinking of as well, how to make things intuitive and work smoothly together. So in that sense, it's not enormously different. You're just working on a slightly different level.
Okay, I have a follow-up for you, Ian, if that's okay.
Of course.
So I've spent a lot of time in startups where we just kind of brute force everything and hope our Band-Aids work. How do you, I'm wondering how much you experience the brute force method versus kind of a more methodical approach to your day-to-day work.
I'm definitely on the brute force side. I've been at Google. I've been at Google for a while now, but before Google, I only ever worked at startups. So I'm certainly familiar with the, you've got to solve the problem of today, and leave tomorrow's problem for tomorrow. So it has been, for me, a learning experience to working on Go, to try to see more and more, like, we have to solve today's problem today, but we have to not pose problems for tomorrow. So that kind of long-term thinking doesn't come super naturally to me, but I've been trying to adopt it as much as I can.
I totally understand.
This is also different in the sense that a language usually outlives products. We don't have all products that we've been using for 30 years, but there are languages that are around for 30 years and we still use them. So that must be also very interesting for you, the type of different challenges and the state of mind that you have to be in.
That's absolutely true. But let me qualify that by saying that one of the things I've been working on for some time is the GCC compiler, the GNU compiler, which supports Go along with several other languages. And I started working on the GCC compiler in 1990. So although most products don't live for 30 years, very few products live for 30 years. In fact, I'm on the GCC steering committee. I've been associated with a product that has lived for over 30 years.
So we're in a good place for Go. You already bring that experience along.
That's longer than I've been alive. I just had like a mind blown moment right there. Okay. Since we've hit that pretty well on the head, let's go ahead. We'll jump over to Katie. We'll talk about security a little bit. Which I'm sorry for. I've dealt with a bunch of security things recently at my job, and I feel like that is the most crap pile-on job ever. Can you tell us?
It's hard because no, go ahead.
Go ahead. Elaborate. Just tell us about your team, what you do, and why a programming language needs security. People don't have programming languages.
Well, it's funny because I've actually been on the security team now for a year, almost exactly. And it wasn't even really a team before I joined. It was just Filippo Valsorda working by himself. And I was wrapping up my work on the checksum database, and I was like, okay, that was kind of security relevant, and I got to learn some things from that. And so I was like, okay, maybe Filippo's working completely by himself. That sounds interesting. I'll go try to learn security with him. And it's been a year and I still feel brand new in the security space. And I think I will for a very long time, because it's a huge field, right? It's not just how do X509 certificates work? Like, how does that work? Or, it's not just one thing. It's like, here's TLS, here's this thing, I'm doing fuzzing. And like, there's so many different areas that I don't have expertise in, and you have to learn all of them. And even like the net HTTP stack, that's where a lot of the security vulnerabilities that we send along actually end up being like fixed in. So it's like net HTTP, someone wouldn't think is a security package, but it is actually very, very security relevant, because if someone can hack your HTTP connection or do something like smuggling vulnerabilities and things like that, we have to watch for that too. So I know I just threw a lot of jargon, and it's okay. And I only understand like half that jargon anyway. So, yeah, right now the team is me and Filippo and a new person who just joined, Roland, and then Rob Klappis, who works with us kind of 20%. So yeah, we have a lot of cool things coming. Like the thing I'm focusing on primarily is adding native fuzzing to the Go language. And I do think that's security relevant because fuzzing has always been something that only security engineers do. And we don't really think it has to be that way. And so the more that just other engineers and in the world and other developers can just add fuzz targets to their code and find vulnerabilities, the better off we're going to be. So that's why it's the security team's effort right now.
Awesome. You just made me feel better about using Go.
Austin, you're the lead for the runtime and compiler team. Mm-hmm. Tell us a bit about the team as well. Who's on the team? How long has it been around? What is it like working distributed? What's coming for the team?
Yeah, sure. I suppose the runtime and compiler have sort of been around since the beginning of the language because you don't have much of a language without a runtime and compiler. They were certainly around before I joined. Yeah, so the team has, the team at Google has about 10 people, and we do get a fair amount of contributions from outside, especially to the compiler. The runtime sort of requires a lot of really specialized knowledge to get into, and so we don't see as much contribution to that from the outside, but the compiler, is, in terms of the techniques that it uses, is a fairly standard design for a compiler. So if you're familiar with working on one compiler, you can sort of come over to our compiler and you'll recognize what's going on at least. So we get a lot of outside contributions there. Let's see, in terms of sort of what's coming. I think a lot of people know that we landed a bunch of improvements to the linker in Go 1.15. There are more coming in 1.16. So even more CPU and RAM improvements to the linker. One big thing that we're working on right now, which I was really hoping to get into 1.16, but it's not going to land until 1.17, is something called a register ABI. So this is how at a machine level Go implements function calls. Which, if you haven't worked at that level, this sort of seems like, well, a function call is just a function call, like it just happens, right? But there's actually a way that maps onto how the hardware implements these things and how the hardware looks at these things. And so, in particular, we're looking at this calling convention. And since the outset, Go has used a stack-based calling convention, which is very simple, but also not very efficient. And so we're switching over to a more efficient calling convention. And we're hoping to see 5 to 10% throughput improvements just kind of across the board from doing this. Another fun thing that's coming is we're adding a new API to the runtime for sort of seeing internal runtime metrics. So the metric can the runtime can sort of monitor lots of things about itself, and then you can ask questions of the runtime. You can sort of export these through monitoring systems or whatever. Partly, I'm excited about that because it will give us a lot more visibility into what sort of user workloads, what what actual applications are doing in the runtime. Whereas right now, we kind of have to guess a lot of the time as to what, like, is this important? Is that important? Should we optimize for this? Like, I don't really know. But we're hoping that that'll give us a lot more data. And then finally, the other like obvious, really big thing that's coming is generics, and that's going to require, we're already in the thick of huge compiler and some runtime changes for that as well.
I didn't even think about generics impacting the compiler until just now. Oh my gosh, I'm not envious of your job. Oh, I can't even fathom that. Oh.
It's great as far as I'm concerned, though. Robert and I get to sketch out a generics plan, and then we just say to everyone else, hey, go ahead.
Definitely true. And all of us on the outside are just like, we just want the generics for our life to be easier. You guys can deal with all of the pain, and we would just love them.
Well, that's kind of like a Go tenet when I think about Go. It's like, how much pain can you cause the Go team and the maintainers, and not like in even a bad way. It's just like, how much complexity can you put in, the details of the language so that when you actually go to write it, it's very, very simple and it just works well. And like, that's very much true with like the crypto packages, and it's true in a lot of the code. It's all like how much, like modules, for example, is incredibly complicated under the hood, but you don't really have to do that much to use it. So it's kind of intentional.
Mm-hmm. This is actually one of the things I really love about working on the garbage collector. Like the interface to the garbage collector is like new, right? New of type. That's it. Like, but when you actually go down into the implementation of it, like it's this incredibly complex system that is tuned in all sorts of ways and has all these really complicated performance properties. But the interface to it is just like as simple as you could possibly imagine.
So you guys are writing black magic, essentially.
I mean, yeah.
Hand wavy.
I mean, fuzzing is actually black magic, so like I'm actually writing black magic.
Okay. Looks like I have a question here kind of about the future, right? We all care about where Go is going. I know people always bring up Go 2.0, like that's so far down the road. We consider that the future. So if you all just want to take, 5 minutes around there, we can go shorter or longer just to address this. What are you looking forward in upcoming Go releases as part of the language in general, or with the stuff you handle? What do you look forward to in the evolution of your language in the near-ish far future?
I can answer that from, so there's the core bits of the language that, the engineers work on to make sure that the complexity is hidden from the millions of, plus users. But there's also a component of, if you've ever, the idea that you can build the best thing in the world, but if you don't build ways to learn it easily, it may not ever see the light of day beyond people who can grok it or learn it in a way that works for them. So for the future of Go outside of that, I would love to see more interactive learning environments, as well as tutorials that people are writing and sharing. So a growing sense of learning material that comes from all corners of the world in all different languages, so that anyone who wants to learn Go from any background, whether they were programming as a young person with BASIC or just coming to it in C++ in their senior year of high school and beyond, that they can learn Go. And so I think that's a really important thing that we're looking at and wanting to make sure that we can help the ecosystem for that. I think the other bits and pieces are everything that the language does in order to hide complexity has to make some trade-offs and choices. And that makes people constantly ask, well, why can't you just add X or Y? And the real, I think the real hard thing is trying to communicate in a way that lets people understand, yes, we recognize that that's an important thing, but the trade-offs are, and then, it could go into like years-long backstory of why or why not that wasn't done. So in terms of the future, I really think of education. I think of talking to people. I think of really making them understand that we would love to make Go grow with more users, but in a mindful way.
Everybody's nodding their head. Yes.
Great answer.
I'll take a stab at this too. You mentioned Go 2, which is a concept we've always talked about as sort of what Go is going to evolve into. But I think it's really worth considering that most major languages, like many major languages like C++ or Java, there is no C++2. There's really just C++, and they keep adding features and adding functionality, but the old stuff keeps working too. So it's not like they ever go to a 2.0 release where old things break and new things, and they only have new things. So I think that's really the model we want to follow for Go. In Go, we want to keep all the old code working. Backward compatibility has been a part of the Go story since Go 1, so to speak. Before Go 1, we used to change the language regularly and break things all the time. But it was really Rob who put a stake in the ground and said, okay, we've done enough work on this language. It's productive enough for people, although of course a tiny fraction of the number of people who use it today. And now it's time for us to just say, this is the language, and this is what we're going to call Go 1. And we're going to be stable from now on forward. People who write code in Go 1, as much as possible, we're not going to break that code for them. Their programs are going to continue to work. And we've been following that philosophy ever since. I guess Go 1 came out in early 2012. And so we don't have any plans to change that. So if there is a Go 2, it'll still be Go 1 compatible, so to speak. And so just like C++ goes, they had C++ 98 and C++ 11, and now they're working on C++ 20 or something like that. But still, the old code continues to work. It's going to be the same for Go. We have, our regular 6-month release cadence at the moment, and we hope to continue that. But the old code's going to keep working. Maybe someday we will say, okay, now it's Go 2, but the Go 1 code will still work. So it'll be more of a, sort of a marketing thing, an acknowledgement of how much has been added to the language rather than a major version change. So that's how I think of it. And that's all about the past. So looking to the future, obviously generics is the main focus right now. Hopefully that can come in the next year or two. I think we're in a really good space for that. And then, there's going to be more libraries. I don't think I don't know of any major language changes coming up. It's hard to predict the future, but it's not like there's any big obvious omissions. There's still cleanups we can do, and we're just going to have to see. But I think that a lot of the focus on the sort of low-level Go ecosystem is going to continue to be on libraries, expanding the libraries, making them easier to use, possibly having version 2 of some of the core libraries. Some of the core libraries, like perhaps the net package, have gotten pretty complicated over the years, maybe too hard to understand, or the net HTTP package. Maybe those can be split up into other packages, and that might be version 2. But even then, we keep the version 1 working too. And I'm really looking forward to the security work that Katie's been doing. Fuzzing will be a great addition. The Delve debugger is awesome, but I think it can get better, especially for programs with large numbers of Go routines, to have a clearer understanding what your program is doing when there's just too much going on to track it at the individual element level, try to get a better concept of the overall program. I think there's a lot of work that can be done in the Go ecosystem to make it easier to use, easier to understand, all in the service of providing a good environment for people to write code in.
That was impressive. Austin, Katie, I know Austin already kind of talked about his immediate release numbers, but what do you guys kind of see in the future of your projects or hope to see in the future of the Go?
Yeah, looking a little further forward, sort of more abstract stuff. I'm definitely interested in improved observability and debuggability. I personally think that when you start sort of scaling up to large numbers of Go routines, the sort of programming that you do in Go, that traditional debugging techniques, sort of breakpoint debugging and stepping debugging and things like that, don't scale that well to highly concurrent systems. I don't know what the right answer here is, but it's something that I love to think about. Like, what would a completely different debugging experience look like that was really designed for these massively concurrent systems? Certainly, like when I'm debugging some really horrible concurrent runtime problem, which is, after all, like most of the runtime problems, I usually start with a breakpoint debugger, and I find that it's just not doing what I need it to, and I almost always wind up at tracing. So just like incredibly detailed traces that are, we've actually have a system internal to the runtime for collecting very low overhead traces. And then I run analyses over these traces. So I'm sort of programming the debugger, and I'm looking at things temporally instead of spatially. I'm looking at how things change over time rather than what the data looks like at a given moment in time. So I'm looking further out. That's something that I'm excited about. And other like further future things that I'm excited about more in the runtime and compiler space is sort of post like the register ABI change and generics. I think there's a lot of opportunity for a few things. One is really more advanced escape analysis. This is in Go, like when you have a variable, it can either be allocated on the stack, which is fast, or it can be allocated on the heap, which we try to make as fast as possible, but nothing's as fast as stack allocation. We've been sort of for several years now kicking around ideas of how could we make the escape analysis dramatically more sophisticated, so that it can keep more stuff on the stack and less off the heap, or something in between that sort of has in between properties. And can we also deal with when you're making interface calls? So there's this odd tension in the language where well-performing Go code depends on the escape analysis being effective. It depends on like, we can put all this stuff on the stack, it's fine. We don't have to put it on the heap. But interfaces are a core part of the language, and interfaces are like oil and water with escape analysis. They basically force everything onto the heap and off the stack. And so there's this weird tension that I would love it if we could sort of find a way to square that tension between these two things, and actually find a way to make interface calls not have the sort of performance penalty.
And I guess I'm last up. I think I'm really excited about the fact that our team has grown as much as it has. Like when I joined, it was still already a pretty big team, which I only joined about 2 years ago. And I feel like so many more people have joined the team in that time. And that's allowed us to do a lot more really cool work. Something else I'm excited about is like pkg.go.dev, which I'm going to link right now in the chat, which if you haven't checked that out, you absolutely should. It's the new package discovery site that Julie Q has been leading with an awesome team. And that's been just really, really cool to see. And, even just like in my world with security, it's cool to see the security team growing and having, like letting Filippo have more support so that we can do more things. We're looking into a vulnerability tracking story, and when we've as in addition to what else we're doing with like fuzzing, and I've talked about fuzzing a bit, and I know I've said that word a lot. I haven't actually explained what it was, but it's basically just a new way of it's a way of testing code by basically just throwing tons of inputs at it, and the computer can throw those inputs at it to try to find panics or bugs and things like that. So I'll also link the proposal for fuzzing in the chat too, so that if anyone wants to read more about how that'll work, they can do that. But like we just have a lot of really cool things that are coming up, and I think that this upcoming release is going to be really great too. So yeah, I'm just excited about the way the team is going.
Thank you all for the answers. The next several questions will come from Slido. So those are the questions that the crowd was asking over the last couple of days. And the first one is for Ian, but I think everybody would be interested to hear everybody's answer if you feel like chiming in. How can new contributors start contributing to the project, and what is the best way to get started?
Yeah, that's a great question. And let me start by saying, Katie's right. It's been great to see the team grow overall, but it's also been great to see the external contributors grow, because a lot of work on Go is not done by the Go team. A great deal of the work is done by people like yourselves, people outside Google. I think, the last time I measured it, something like half of the changes to the Go repository were made from outside Google. So that's been great. It's been an amazing set of contributions, and it's really made the language much stronger. And in the libraries and the documentation and everything, And it's not just contributions to the Go repository itself. There's things like the awesome Go repo and many other tutorials and blog posts explaining how to use the language. All of these things have really helped make the language and the whole overall ecosystem much better. So how can contributors who do want to work on the main Go repo, what can they do? We have, so if you're just starting from scratch and you're not sure what you want to work on, go to the issue tracker, look for the Help Wanted label. Now, the Help Wanted label is a range. Some of the things on the Help Wanted are pretty simple, like we need better docs here or something like that. Some of the things on the Help Wanted are pretty complicated, so you're going to have to use a bit of judgment there. But, take a look there. Those are areas where we know something needs to be done. We may not know exactly what needs to be done. We know something needs to be done. And we also know that we're not going to get around to it soon because we have too much work to do ourselves, and it just doesn't seem that critical, but it still would be helpful. Or perhaps you have a specific area of interest. I tend to work on the lower level stuff, so that's what I would gravitate toward. But maybe you are like HTTP, maybe you like HTML. These are all areas in the standard library that can always use help. Maybe, we recently got a contribution to rewrite the conversion of floating point to ASCII. I think that's going through review right now. So, that's a pretty low-level technical detail, but can speed up all those programs that print floating point numbers, which is quite a few of them, and make the results more accurate. I think there's a lot of ways in, and we really welcome new contributors, and we have the Slack and the GoLang Nuts mailing list. There's a lot of places where you can sort of say, this is what I'm interested in. Can anyone give me a little guidance? And we'll try to do our best to answer questions. It's hard to answer a general question like what should I do, but it's easy to answer a specific question like I was looking at this and I didn't understand that, and then we can say, well, this is our view of it. This is what we think. So. If you're interested at all, jump in, help, and and ask, because we're here to help you.
We also have, a number of really great contributors who do things like issue triage and gardening, which has often been a huge burden on the open source team. It's actually for a long time it's been possible by the help of people in the community. Rather than putting all the burden on just a couple people on the Go team. And so it doesn't even have to be code contributions. It can also be going in the issue tracker and making sure that all the information is there and the right labels are in place and the title is good, and engaging with people and answering questions on Slack. And there's tons of different ways that you can contribute that aren't code at all. Depending on where your skill set is or how much time you have or what you're interested in.
Any other thoughts? I don't want to cut anyone off, but Cool. Okay. Kind of continuing on this vein of contributing and open source, all that stuff. We've seen recently, well, I mean, at least I have noticed, the Go team has been doing a lot to kind of encourage new tooling and great resources for developers that are very much open sourced, and cool thing, just great opportunities for people to be able to improve their development process. How do you guys manage like monitoring these new tools or doing bugs, or like how do you factor in community input on the stuff that you guys work on internally?
So for tooling, we have a tools working group, and it is not actually led by or coordinated by the Go team within Google, but rather what we call the Go team community working group, which is sort of our, to use a sports analogy, like your 11th football player. And they meet monthly, and you can find all the information about what they talk about, what they do. They work very closely with the engineers to submit changes to things like the Go command, which consumes a lot of these tools. They also work with some of the subteams for tools in our editor and the language server, so we call it Go Please, and the VS Code integration therein. We have, in addition to the main issue repo, there is a Golang/tools repo where you get to see a lot of that collaboration again. And if you go to that repo within GitHub, you're going to see ways to get involved in the tools working group, to join in. Anybody can join the tools monthly the call. And Gopher Slack, if you haven't joined Gopher Slack, I would recommend that, because there's a tools channel in Gopher Slack where many of the Go team contributors, as well as those in the working group, frequent, and you can get a lot of the questions answered, things discussed there as well.
Awesome. I've seen that in a lot of other large open source projects where they kind of have the monthly call, and they have kind of the idea of ambassadors who only do third-party work. I know that's very common with CNCF projects to have the people that aren't directly on the team, but are kind of ambassadors who are directly involved in that. And it's really, I'm glad to know that the Go team does have that outside perspective that's constantly working on those tools. That's pretty cool to me.
How does the Go team manage iterating proposals like the generics proposal when it was, or Go, and how do you manage the implementation as well? Open question.
Ian, do you want to take the proposal review group, and I'll link in some of the process things in the chat?
Sure. Okay. Yeah, there's a small proposal review team that is currently 5 or 6 people, and we meet about weekly. And there's people at Google and a couple people not at Google now on it, but everyone used to work at Google at one point or another. And we review proposals. For those who don't know, there's a whole proposal process at Go, which you can see at golang.org/s/proposal. And so that's how we solicit suggestions for changes to the language and the standard library. And then in the proposal review committee, we review those proposals. And a lot of what we try to do there is route them to the appropriate people, to the people who are most familiar with the packages in question. We try to elucidate what exactly the change is, how it would work out, and we try to drive for consensus. Basically, I mean, we're not trying to be a group of people who decides what happens. We're trying to be a group of people who gets input from the community, gets input from the right people in the community, and try to see what people, what the overall community really thinks should happen for these cases. And you know, a lot of proposals get declined. I've made a lot of proposals over the years, and almost all of them have been declined. You know, that's it's a normal. It's how we sort of evolve the language and libraries going forward. So now I've lost my train of thought a little bit. But that's you know, that's sort of the change process. There's also kind of a separate process for sort of specific to language changes like generics, which is the go-to proposal committee. And there we review language changes to try to see you know, what would be appropriate to add to language. And frankly, almost every single one of those proposals gets declined, but they've all helped us to understand the areas in the language where people are running into trouble, areas where perhaps we can find some way forward, some change that will address these, perhaps in language, perhaps in the libraries, perhaps, you know, in the documentation.
Some procedural changes were made recently as well after discussion with many contributors last year at the GopherCon San Diego Contributor Summit, where we had some clarity and transparency in the GitHub issue repo. So if you're interested, there is a meta issue, I'll try to find it, where the weekly discussions that happen with Ian and the group are pasted there so that people can understand what's happening in that room, but also procedural things like there's a final comment period for when something looks like it's leaning towards accept. And we want to make absolute sure that everybody wants to get in any kind of last comments in that issue thread, or if they have strong objections. Thank you, Gianni listed it. It's the issue 33502. And you'll get to see what gets discussed there every day. So that helps give a little bit of, for those of that are interested in that kind of detail, the transparency that you probably would like to see.
Okay, that's awesome. Thank you guys so much. I'm not trying to end it. I'm just saying we've made it through a whole hour, guys. It's gone super fast. So we have another hour of exciting questions. But we just kind of, before we start wearing out our little thinkers, let's go ahead and we will spice it up a little bit. Do you guys have a favorite bug or problem that you like hacking on, working through, debugging? Please do not say spiders or nil pointer to reference. Those are not acceptable answers.
I had one recently that was a lot of fun and also somewhat terrifying. So when we implemented asynchronous preemption in the runtime, so this is sort of the ability to stop a Go routine while it's in the middle of a tight loop. So we did this using POSIX signals, at least on Unix systems. And when we actually needed to stop a Go routine, we could sometimes send it a whole bunch of signals. And so we did all simple implementation work. We rolled it out, and then we started getting bug reports, people saying that like their programs were randomly crashing. And this is a fairly invasive change, and we're like sending signals to Go routines that are at random points, and it's like, oh no, like what did we screw up that's just like randomly corrupting memory in this? But then as we were digging further into the issue, we realized, actually I think it was an outside, like an open source contributor who sort of put this together, that it was only happening on specific versions of the Linux kernel. And then so we're like, oh no. And so we start digging into this further, and what we figured out, I forget the exact order that we figured things out in, but we figured out that it was actually sometimes corrupting vector registers. So this is a particular subset of like the CPU state. And in particular, we use that for memory copying and memory zeroing. And so if you corrupted your vector registers while you're in the middle of a memory copy or a memory zero, then like it could just like spread that corruption sort of arbitrarily through your memory. And so I started up like a bisect on the Linux kernel itself. So I spun up a VM and started bisecting, like building lots of versions of the Linux kernel, trying to figure out exactly what version or what commit to the Linux kernel was responsible for this. And meanwhile, we're like, doing everything that we can to try to figure out what's going on here. And it eventually turned out that there had been a change to how the Linux kernel handled signals, and specifically sort of saving the CPU state when a signal came in. And they had introduced a point where the code that was actually like handling the signal inside the Linux kernel could switch from running on one CPU to switch to running on another CPU. But the code wasn't written such that this was safe. Like it assumed that the whole thing ran straight through on one CPU. And this hadn't actually mattered before unless you were also compiling your Linux kernel with GCC version 9, which had introduced a new optimization, which was itself a perfectly fine optimization, but that revealed this bug in the Linux kernel and made it so that the code could break when it moved from one CPU to another. And so you needed to be running a new version of Go on a pretty new kernel compiled with GCC 9. And it was just this like whole stack of really complicated interactions between all these pieces of the system that finally all came together. And it was a really fascinating bug to work on.
Yeah, I think the interesting bugs are the ones that are like what Austin just described, where there's some kind of layering violation. We're all used to computers being these layers, where each new layer insulates you from the layer beneath. I mean, we start with the hardware and the operating system, and then Go itself is a layer. Then people are writing in Go, and so when you're writing in Go, you just expect to be writing at the Go layer, and you don't expect some kind of hardware problem to reach up and grab you, or some kernel bug to hit you. But unfortunately, computer programmers are mortal, and we all make mistakes. And there are these layering violations, these leaky abstractions, people sometimes say, and those are inevitably the most interesting bugs to run into, because you have to sort of switch your mindset out of, okay, I know the world I'm living in, to realize that something from the netherworld is reaching out and breaking your code.
The netherworld is now attacking us, guys. It's been officially declared.
Nice visual, though. I have an interesting answer to this question, and it moves away from the technological to the socio-technical. So I deal with a lot of what I call perception in open source. And if you asked any Go programmer, what does open source mean to you? You're going to get N+1 different answers. And I think my debugging is often trying to get to what their assumptions are about what open source should be, beyond simply making the code open. And so it's become a long journey, because some people in the Go community may get very frustrated because we may have violated some sort of hidden expectation of theirs, right? In terms of ways that we shared things, or ways that we communicated, and things that we maybe failed to do that they were expecting. And then it becomes a whole journey of talking about this kind of open source, maybe open production, maybe consensus seeking, the rules of engagement, the social contracts, the collaboration. And I really, since I left the technical when I came to Google and walked into the socio-technical, and it's been really interesting, because human assumptions don't compile neatly, and human emotions don't compile neatly. And so that's been a really interesting problem space to debug.
Yeah, I don't know if I don't have like a really cool story about a bug I've debugged. I mean, in general, I think security has been kind of fun because trying to figure out if something's actually a vulnerability and the scope of it and what it means for people. I mean, it's not just, is this wrong? If it was just, is this the wrong behavior, that would actually be pretty easy, but it's not that. It's this kind of multi-layered thing where, okay, it's wrong, but what's the impact of that? Or is it wrong, but it's already just documented that it's wrong? Or if it's wrong, can we fix it, or is it going to break backwards compatibility? And is it bad enough that we should fix it anyway, even if it does break backwards compatibility? And there's all these issues that are really, really nuanced and take, if anyone's ever submitted a vulnerability report and don't understand why it takes so long, it's because it's just so much analysis about what is the impact of this, who exactly is going to be affected by it, and what's going to happen. Is their server going to go down? Are they going to get DOSed? Is an HTTP smuggling vulnerability where somebody could do something really, really bad to someone's server and an attacker could access information that they shouldn't be able to access, or do things they shouldn't be able to do, or is it something that somebody can, is it user error that can cause it, or is it an attacker can cause it, or is it just is it on which platform is it on, and there's so many factors that are just really complicated. And when we have a security vulnerability and we have a bug like that, we have to make sure that when we fix it, we've explained in the release, this is exactly who is going to be affected, and here's what you need to do to fix it, so that people don't, stay up all night trying to figure out whether or not they could potentially get DOSed by some issue in the net package or something, So it's really nuanced and really complicated, but it's kind of fun too, because there's very much a human aspect to this that I really like. Yeah, it's cool. Enjoy it.
I know that in security, you always have these bugs where someone comes back and says, you've broken my program, and the response is, well, your program has become insecure, so it's
Correct.
Good that it broke. But but you've broken it.
Yeah, yeah. I mean, yeah, deprecating things. I think that Filippo was trying to deprecate something that has been in the standard library that has been deprecated for something like 10 years or something like that. And it has been known to be deprecated for many, many years. And some people were still using it and said, hey, you broke us. And we're like, it's been gone for 10 years. You got to change it, but it's hard because backwards compatibility is a promise, and we have to try to balance what's the right thing to do to make sure that people are getting security by default, but without making people lose trust in the language. And that's really, really hard.
I do want to call out Adam Langley in particular, by the way. He worked on Go in the very early days, and he's the reason why Go has such great security support. He's a security engineer here at Google who's been very influential in the whole space. And he used to just come sit with us a couple of days a week, and he would just code in Go and write security support. And so for a while, in the very early days before Go 1, it was the biggest part of the whole Go standard library was all the crypto support.
Yeah, no, thanks for calling out, Adam.
In addition to security, I guess concurrency is one big thing in Go that has also been there pretty much from the beginning. And the next question is, are there any plans to add support for concurrent data structures similar to ThinkMap, but for lists, sorted maps, and so on?
Yeah, I think that's going to be a very natural next step when and if we add generics to the language. Part of the reason we don't have those concurrent data structures is because in today's Go, they have to be written using empty interfaces. There's no way to write a compile time type safe container in Go as it exists today, and that's exactly what you want for a concurrent data structure. It's not the only thing you want for a concurrent data structure, but that makes it the most straightforward and easy to use. So I think that after we have generics, it'll be a very natural set of additions to add a not a large set of containers, but a small set of containers that we don't have today. And one of the most obvious ones was going to be some kind of concurrent map that's, along the lines of sync.map, but sync.map is fairly specific. There may be a few different concurrent maps with different properties that people want. We're going to be looking to other languages here to see what they provide and what's going to be most useful for Go programmers. So yes, definitely after generics, concurrent data structures and other general purpose data structures.
And do you ever get tired about talking about generics?
I guess not.
I feel like it's just come up so many times, and the answer is always generics, but like not generics. Anyway, it comes up a lot. So let's switch off of it for a minute. We'll give you a break. Today we got a question about Go's garbage collector, and it sounds like Austin brought that up and decided to inspire this question. So if you want to address it, feel free. If not, anyone else can. So I hear great things about Go's garbage collector. Is it true that most pause times are between 10 to 100 microseconds? Do you ever compare this to other compilers, and what processes do you use for benchmarking or doing metrics on the garbage collector?
Yeah, definitely. Well, thank you for, the garbage collector is a lot of fun to work on. It's a lot of very algorithmic code and, very performance sensitive, obviously. So yes, it's true that basically pretty much all pauses at this point are like in the below 100 microseconds. We actually usually they're even less than that, but that's sort of the bound that we try to go for. That was many years worth of work. Like we released the concurrent garbage collector in Go 1.5, and at that point we sort of said we'll sort of try our best to keep pauses under 10 milliseconds, which is pretty good. Then over the next several years, I sort of had this like big ongoing project of just systematically squashing every source of increased pause times. I literally had a list of like, these are all of the things that can increase the pause time. And we were just sort of working through that. And that was a lot of it was just like good old engineering work, and some of it was like novel algorithm design, which was a lot of fun. In terms of comparing it to other runtimes, we tend not to. I don't know. I don't know that the comparison would be particularly useful, but we definitely do, like the whole work on the concurrent garbage collector was motivated by the sorts of things that Go is used for, right? Like we were looking at Go being used for all of these like distributed RPC systems and things like that, and before we had a concurrent garbage collector, we had a stop the world garbage collector, and the time that it took was proportional to the size of your heap and like the number of Go routines and all sorts of things, and it would just stop your program for that amount of time. And that's bad when you have a single RPC server that you're talking to, because you might happen to get caught in the middle of one of these stop the worlds, and it takes a while to hear back. It's a lot worse when you have a distributed system, because you're sort of increasing the likelihood that you'll hit some system that's stuck in the middle of a stop the world garbage collector. And so even these tail latencies, they become less and less tail as you have a bigger distributed system. And so at the time, this was sort of an existential threat to Go. And then, as we moved towards shorter and shorter pauses, it became really a thing that we really wanted people just not have to think about at all, right? You just shouldn't be worried about garbage collector pauses. This isn't a thing that should rise to the level of a user concern. And so I think it's really nice to be at that point right now. We've got a few like really tiny cases where we know that this can still go over, and those are still on our list of things to fix, but it's basically all there. And the way that we monitor this is, you can sort of the garbage collector can kind of introspect, right? Like it can look at itself and it can measure its own pause times. That's not hard. And so we do expose those through metrics, and like at Google, we can actually sort of collect those metrics from the fleet and look at, what do our pause times actually look like. In some sense, that's actually not that interesting. What you really want to know is what is the end-to-end effect on the actual systems, on like RPC latency and things like that. That data is a lot harder to get, just because you have lots of different systems. Like for a given system, it's maybe not that hard, but when you have 100 different systems written in Go, like how do you ask them all what's the effect on RPC latency or any sort of latency or whatever? So we have benchmark collections basically. We have a few different benchmark collections. We have sort of micro benchmarks that we've collected from the community. Those are good benchmarks. They tend not to be that useful for garbage collector work, just because they usually have like small heaps because they're micro benchmarks, and latency doesn't always make sense in them. And then we've got another suite of like application level benchmarks that Michael Knishek put together. And those tend to be actually quite useful for garbage collection measurement and memory manager in general. So those actually will like spin up whole, like geospatial database servers and stuff like that, and hammer them and actually measure these sorts of end-to-end performance properties that we're actually really going for. So that's how we drive a lot of our work, and also talking with big customers, like trying to get profiles from them and understand the latency impacts on them.
Awesome. That was a lot of crazy stuff, and I'm glad that in my 2.5 years using Go, I've never run into a garbage collector bug that I've had to deal with. So Austin, I do have another question for you, brought up by some previous comments. You were mentioning tracing in the past.
Mm-hmm.
And the question is, what is the most elegant way to trace an individual Go routine?
Trace an individual Go routine.
Not something I want to deal with, but if you have any thoughts.
Yeah, I don't know. There's not actually a fantastic way to do that right now. There's definitely a tension there. Like, sort of a kind of basic concept in the language is that Go routines don't actually have an identity. Like most languages have like a thread object or a thread ID or something like that. Something that gives you sort of a first-class handle on a piece of concurrency. Go routines don't have that. Go routines are completely anonymous. They just sort of exist out in the ether. For the most part, I think that's actually what you want, because you don't want to, like, it is basically almost always a mistake to associate anything with the identity of a Go routine, because once you get down into libraries and things like that, those libraries are free to like create other Go routines or parallelize the work or whatever. And so if you think you have a handle on the Go routine that's doing something, the moment you call out into code that you don't control, like you don't really have a handle on what's actually going on in that code with its concurrency. The one exception to this that seems pretty legitimate is actually tracing. That you really want to understand, like, I'm really just going through some sequential code here, and I'd love to have a way for tracing to understand that this is really just a sequential block of code. So I actually don't have a good answer here. I mentioned that down in the runtime, we have an internal mechanism for doing super lightweight, like in-memory ring buffer tracing. That has access to what Go routine it's running on. Yeah, we don't actually have that's sort of one kind of blind spot in the runtime is if you want to trace and sort of introspect on sequential execution, there's not a good way to get at that identity.
Awesome. Thank you for your honesty. Yeah. Natalie, you want to take the next question?
Yes, and I also want to unmute myself. Always
Okay.
important in quotes. It's like bingo, and when whoever had this on their list of cross this out, it happened just now. So the question is actually maybe for Carmen and Ian. It's a little bit of a past and a little bit of a future question. So Go had a lot of traction and adoption recently in the DevOps community, and it's also being used for infrastructure in general. But in the beginning, at least my impression is that Go was used mostly for applications. So there's also a growth of Go in the cloud native space. So in the beginning, how did you imagine Go? Where would you see its main uses? And now, what kind of heavy adoption do you see for upcoming spaces?
Well, I'll do the in the beginning question, and you can take the rest. I think in the beginning we thought Go would be used for infrastructure. We thought Go would be used for servers. I mean, our vision was basically you can write your web server in Go, you can write your RPC server in Go. That's what we were originally thinking. I think that then it pretty quickly developed that a lot of people started using it for places where they had previously been using Python scripting. They picked up Go instead for the efficiency advantage and the static compile time type checking. So that actually caught us a little bit by surprise. That wasn't where we thought the first growth of Go would be. And here I'm talking, sort of the 2012 timeframe. So it's changed a lot since then. But we did originally envision it being used for infrastructure. And then, of course, Docker came along, written in Go. That was one of our first huge successes outside of Google itself. It's just gone from there. I mean, of course, it can be used in many different areas, and it has been used in many different areas. But that's how we were thinking originally.
Yeah, and I think in terms of adoption, the philosophy still remains part of the headache that the original founders have often talked about was that Go was created during a 45-minute wait time when a C++ program was compiling. And they just felt like the process of software development had gotten overly complicated, right, with all these callbacks and an inverted style of programming. And they just wanted to keep it simple. So at its philosophical heart, Go's main goal is to be that good all-purpose programming language at scale while not getting the bloat. And I think that the bloat over the years from some languages in order to try to appeal to different programming verticals, whether it's networking or infrastructure or web, I think Ian and what I would call the stewards of the language have been very thoughtful about making sure that the bloat doesn't happen, at least in the standard library. And also there's the 1.0 compatibility promise. Having said all that, there are a growing number of libraries in the ecosystem for gaming. Google has a dedicated gaming server written in Go called Agonus, and there's an ecosystem that's growing around that. There's a growing number of libraries and the community and ecosystem for data and data science. Lots of support for embedded and IoT. Google gave a large sponsorship to TinyGo with its LLVM-based compiler for embeddedness. So I think that the adoption would be if Go seems to work because of if the properties of the language help it to work based on whatever the programming situation needs. Go seems to be a good fit. I think that the last piece of this puzzle for adoption is being able to support people with proper documentation, onboarding, education.
Awesome. I can attest that I use a lot of the Go data science packages, and I think a lot of people spend a lot of time just developing these third-party tools, and they're really incredible. So I think we should all use them as much. They're still Go. They're just as awesome. And they really do provide a lot of awesome tooling. So we have a question here about, looks like we're going to jump back into contributing to Go. How has the contribution process changed and evolved in the last couple of years, especially considering how Go's popularity has grown?
Well, Ian touched on that a little bit, right?
Yeah, for sure.
over the year, so starting in early 2019, the milestone happened where the equal amount of people from inside Google and outside Google were programmers. And now with each year, it's like 51% external. And I would think that's the change. And every year we're going to see more and more external contributors. But one of the things that surprised me when I came to Google for contribution was that Go has seen like 3 different version control systems in its history. And I think they finally decided to work with Git and Garrett, or Garrett on 4.
That's crazy.
Right. And I think with the advent or the popularity of GitHub, they decided to mirror the code to GitHub, but that decision wasn't made until 2015. But that's still only a mirror. And I think that the changes, what people find is that the GitHub workflow works, but there's been steady improvements by the open source team to help what we call a shim or a tool on top of the Garrett workflow to happen so that you could submit PRs and then they get translated into the Garrett workflow for CLs. So that's one of the changes, as well as these things we talked about. I don't know if you have anything else to add to that, Ian.
I think that one of the things we're trying to work through is how to do the review process better with the ever-increasing number of external contributions, because the external contributions are great. A lot of them do need some attention or tweaks to kind of maintain the maintain the maintainability and the portability of the libraries. Not every contributor has obviously all the experience with the problems that they can run into. So, we need to make suggestions, and we need to make sure that the changes are appropriate and good for the ecosystem. And I think it's been, we're struggling right now, I have to say, with keeping up with the flow of external contributions. We really want the external contributions to continue, and we need to keep working to figure out how to make this work well to keep the ecosystem going forward. And there have been external people who have been extremely helpful in this too, in triaging the initial set of contributions and helping people, even simple things like get the commit messages into the form that we like them, and make sure that there's tests and make sure that the tests pass. The open source team has, based on Brad Fitzpatrick's work, they've got this great set of, we call them Go modes, but just different builders of all the different systems that Go supports, and there's quite a few now. But we're still, as I say, trying to figure out how we can grow our review capability to meet the growth of external contributions.
I need to head out, everyone.
Thank you so much. Yeah. It's been amazing. You've given us so many insights today. I can't say thank you enough.
Thanks. Bye. Enjoy.
Okay.
Looks like we lost Natalie, too.
Yes. I think she's had some connectivity issues on her platform, but I'm sure we'll see her back in a minute. So I'm going to go ahead. And I have a follow-up I think, with the contribution process question. But you guys are working on a programming language that's used by thousands, hundreds of thousands of people every day for a variety of reasons. Do you feel a lot of pressure from the users to implement certain things or change certain things? Do you have to cope with that? Do you feel like you're sheltered from that? How do you interact with the community, I guess, in your development?
We do have pressure might be too strong a word, but there's definitely constant requests for things, in the libraries, in the language itself, to make things easier for external contributors. So there's always a balance we're trying to strike. This might make life really much better for you, and we understand it will make life much better for you, but it will make things harder for everybody else and harder for Go programmers. Of course, that's the extreme case, but we're trying to. It's definitely a balance. But pressure is too strong a word. I mean, it's just part of the work of maintaining the overall ecosystem. I would say is trying to make these judgments, balance present needs and future needs, and try to make our best call and try to open it up to the community as much as possible. I mean, if everyone out there is saying we need this, then we need it.
I think I have a better way to put it. Just, I guess in my job, we deal a lot with the idea of stakeholders, right? And we can usually put stakeholders into like small groups. Like, so we'll have 3 or 4 stakeholders for a specific product. But you guys have like thousands of stakeholders across a different variety, so many different ecosystems. I guess, like, how do you manage all of those stakeholders while building, such a fundamental thing? That's the better question.
That is a good question. I guess what we try to do is identify those stakeholders. I mean, they're inevitably the people who are willing to contribute. I mean, from our point of view, that is, it's the people who are willing to talk, willing to be open to conversations. And so, there's a lot of those people out there. And when we get a suggestion for some change in some area, we just CC those people and say, hey, what do you think about this? Like people who are familiar with databases, people who are familiar with, I don't know, the DNS system or networking in general. There's a lot of people we can reach out to, many of them outside of Google. And we do that. And those people are very generous with their time. And they help us understand what the needs are out there. But, there's an inevitable hole with that, which is that there are areas where, for whatever reason, there isn't a visible spokesperson for that area. And right now, that's going to be kind of a blind spot for us. And I hope that people will keep alerting us to those blind spots because by their very nature, it's hard for us to see them.
For sure. Do you have any thoughts, Austin or Katie, on this?
Yeah, I mean, one group of kind of stakeholders, I don't know if I would call them stakeholders, but a group of community members are the people that submit vulnerability reports. Those people don't have to submit their vulnerability reports to us if they choose not to. And it's kind of by their own goodwill that they choose to tell us about those things rather than exploit them themselves or, do something else bad with them. And so it's really important that we listen to the people who are taking their time to write very lengthy emails to us that explain in detail what this vulnerability is and the impact of it. And often we have to go kind of back and forth with those people to get more information. Sometimes entire research teams that have written a paper that they send us, people that are spending a lot of time on something that's really important. And it's important that we maintain a good relationship with them and are very transparent about our timelines and about what we're doing and about whether or not it's going to be in a security release or if it's going to be in just the typical release. And yeah, I think that those people are amazing people, and we value them a lot, and we want to maintain those good relationships with the community with that. Yeah.
Austin, do you have any final thoughts for us?
Yeah, I think Ian and Katie already said it pretty well. In the sort of stuff that I work on, quite often what we wind up having to balance is performance concerns. It's relatively rare that you have something where it's just a performance win for everybody. Certainly you do have that sometimes, and then you just do it and it's great. But quite often we have to say like, well, this will make this type of thing faster, but this type of thing slower. And that can be a tricky trade-off to make. And so we try to gather input on that, and we try to make our best guess about like, is this going to help more people than it's going to hurt? And things like that.
And there's always a trade-off between runtime and compile time. And then there's the trade-off between runtime and the size of the executable. Those are all trade-offs that different people, I mean, for very legitimate reasons, different people have very strong opinions about.
Yeah. And we actually, that's a good point. We see this a lot with binary size in particular. Like, most people do not care. We could make the binaries twice as big, and I think a lot of people wouldn't even notice. But some people really care. And so it's one of those complicated trade-offs. So basically, like with binary size, we try to keep it in mind. We try not to do things that would blow up binaries too much, but we tend not to like sacrifice significant gains that we can make on other dimensions just to keep binaries small.
Usually when people want small binaries, I just say, look at TinyGo. But I guess that applies to you too. So I'm sorry. Cool. So, Katie, you've brought up fuzzing a couple of times. Probably that's what you do day to day anymore. And you mentioned the proposal for it. Do you kind of want to hit on why that's important for right now, and if you enjoy working on that?
Yeah, I'm happy to. Yeah, and I talk about it, I've mentioned it a couple of times because it's kind of like my world for the last 6 months to 9 months. And it's been fun because I've never worked on like an actual kind of like language feature. I think the checksum database was really fun, and maybe that would be considered a language feature too. But that was more of like a service that people could use to make modules a better user experience. But I think fuzzing is really important for a lot of different reasons. And I think that it's important now because, this isn't a new problem for Go. People have brought this up for a really long time. There's been an issue. I don't know exactly when it was from, but it's several years old. And there's been a lot of work on this already. Like, I'm not the first person to work on this problem or think about this problem by any stretch of the imagination. I think it was originally filed as an issue by Brad Fitzpatrick a while back. But some efforts has happened in the last 5-ish years. One of them has been Go Fuzz. It's Go-Fuzz. I have to clarify because there's so many different slight variations on Go Fuzz or Fuzz Go or whatever. So Go-Fuzz was something that Dmitry Vukov worked on for a while. This was somebody who was previously on the Go team and is still at Google and is just very, very passionate about fuzzing and is still working on fuzzing in some capacity, just not directly on Go. And Go Fuzz has been used by a lot of people for a while, and it's been a really nice way to fuzz Go code and find vulnerabilities and find issues. But it has had some limitations as well. It's not fully, native support in the language. You still have to install something new, you still have to build it and run it separately, and you have to kind of learn a new system. And it doesn't use some of the compiler instrumentation that's been new that Matthew Dembski's worked on, which can give us better coverage information, which can be a really, really helpful kind of feedback mechanism when we're trying to figure out how to fuzz something. And so we have a lot of work that people have done for a lot of years, and we have tools now that, like the compiler instrumentation and things like that, that we feel means that it's ready to be worked on. Like we think it's a really good, compelling case to have this happen now. So for several months, I worked with various members of I talked to some people in the community. I talked to some Googlers to try to get a proposal out there that would make sense for people. And that took a long time. It took a lot longer than I thought it would to have something that had a really good UX that people could be excited about, that actually made sense and was easy. And I wanted the main goal of that proposal to be that if you already know how to write a unit test and you already know how to use the Go tool, then you can basically learn how to write a fuzz target and run it in just a couple of minutes. And I think that is hopefully going to be the case. And so we've been prototyping it and working on it. It's been fun. So yeah.
Come on.
I'm trying my luck with a mic now. I think it's working.
Hello?
So I resized the screen and then was on the adventure of the way back, but I'm very happy that it's managed, that it worked out. And that, Austin, I want to ask you, the new linker that was released in 1.15,
Complete re-implementation to be faster, use less memory, and generally avoid more work. This is something that was pasted about that, so from the release notes. And can you talk a bit about that and how it made Go better?
Yeah, absolutely. So there were basically three things that we were really trying to do with that work. They were the linker CPU time, or wall clock time, really, the linker memory consumption, and just the maintainability of the linker. So, looking at sort of the resource consumption of the linker, the linker has this sort of problem that it's on the critical path of every Go build. So for those who haven't looked under the covers of how exactly Go software gets built, when you do a Go build, it sort of finds all the packages that have changed, all the source files you've changed and what packages they're in, and then it can compile those pretty much in parallel. There's some dependencies in there, but it can usually fire up a whole bunch of compiler instances all simultaneously. And then once it has all of the packages that you need compiled, it hands them all to this one big final link step. And the link step is what gives you your final binary. And this means that, usually, like if you're compiling something from scratch, like you just did a Go Git or a Git clone on something or whatever, then like it's got a lot of work to do, and it's going to compile a whole bunch of stuff, and then you probably won't notice the link at the end. But if you're actively developing something, like you change a few lines of code over in this package, well, it's going to compile that package, maybe a couple of other packages, and then the linker still has to do this complete link of the entire binary. And so when you're doing this sort of incremental development work, the time that the build process spends in the linker is something you can be really sensitive to. And the old linker kind of came like fully formed out of Ken Thompson's head. And it was very much a Ken Thompson style, like 1970s kind of linker, like designed for C code. It didn't, at the time, it wasn't really designed to scale up to the size of large Go projects these days. And so there were a lot of just like really basic design decisions that sort of pervaded the linker that made it slow when it came to linking really big Go projects, and that made it consume a lot of memory when you were linking really big Go projects. Enough memory that sometimes the linker would just run out of memory. Like you didn't have enough memory to link these really big things. And so this was a problem. And so the sort of linker, we like to call it a renovation rather than a rewrite, because it's not like we sat down and like started at package main and started writing a new linker. We actually took the old linker and rewrote it incrementally. So we introduced a totally new internal representation that was really designed around Go. So I mentioned it before, it looked very much like a C linker. Now it is a Go linker. It is designed for Go. And so we introduced this new representation for the internals of the linker right at the beginning. And then there are a whole bunch of steps. There are like 20 steps or something in the linker. And we kind of pushed that new representation through one step at a time. And then however far we'd gotten, we would do this big chunk of work to translate the new internal representation back to the old representation so the rest of the linker could run. And we just kind of pushed this through until we got it to the end. And then we could delete that translation step. And so now, it's about twice as fast. It should get even faster in 1.16. It uses about half as much memory, and it should also use about another half as much memory in 1.16. And so those are all like real concrete improvements that Go developers should benefit from. And the third reason we did this was really the maintainability. Nobody wanted to touch the linker. It was a terrifying code base that nobody understood. And this actually prevented us from making changes that we wanted to make in the toolchain. Like changes we wanted to make in the compiler that would need some linker support, and we just said, like, no, nobody wants to touch the linker. This is too scary. And so now that we've actually sort of done this process of going through the entire linker from front to back and really sort of improving it and rewriting it where it made sense, now we have a linker that at least 3 engineers actually understand what's going on. And we've had other people since then take a look at it and be like, oh yeah, this actually makes sense. I can make changes here, which is great, because nobody said that before. And so now we're actually in a much better position to make further improvements to the compiler and the linker and the whole tool chain that wasn't a position that we were in before. So hopefully Go developers will benefit in the future from those sorts of things.
That's crazy. I never thought of you guys as actually dealing with legacy code.
So parts of the tool chain were actually, they used to be written in C. Part of why we're sort of dealing with legacy code is like the linker was originally written in C, the compiler was originally written in C, and they several years ago now got automatically translated to Go. But if you think of somebody who's like been programming in C for a long time and they've just started learning Go, like you can tell that they're kind of writing C and Go syntax. This was literally that. It was literally an automatic translation from C. And so just like none of that code was sort of adiabatic Go, and it wasn't very efficient Go code because like it had been written in C before.
And not only were the compiler and linker written in C, they were not written fresh for the Go project. They were based on the Inferno compiler and linker, which Ken Thompson wrote in the 1980s. So yeah, there's definitely legacy code there.
I've never heard of the Inferno compiler, so you guys I've learned so much today. My head is just, I can't comprehend all of this crazy stuff.
It's sure that we can all watch again, like rerun some of the parts. I'm pretty sure there's some parts that I would like need to hear twice or slightly slower or something.
Well, we do all of this hard work, so you don't have to worry about it.
Well, on behalf of everyone, we definitely appreciate this. So thank you very much. Thank you for being smart, and thank you for agreeing to be smart for all the users.
Thank you for letting us work on this. If we didn't have any users, we would not be working on this.
Then I guess with about 10 minutes that we have left, we have a great question to ask everybody as one last round question. What are some surprises that you've encountered over the years working in Go? And no spiders to this as well, but are there any notable bugs or anything that you didn't expect? Other than cats jumping on tables?
I mean, a small thing is just, like I said, I joined the Go team and I started learning Go on the Go team. And to be perfectly honest, at first I didn't like it that much. I mean, I had come from Java, from years of Java, and it's kind of a hard transition, it's not that difficult to learn, but I did find that it wasn't the syntax that was hard to learn. It was how to write Go code that looks like Go code. I think for a while I was writing Go code that was just Java code that was just written in Go. And it was structured like Java with like getters and setters and all those things. And I was just writing it in Go. And it took me a little while to actually learn how to think like a Go developer and think in the way that is actually productive for the language. So yeah, I think that I was kind of surprised by how much I actually ended up really liking the language. And now, after working on it, I mean, it didn't take very long for me to kind of get the hang of it, and start to kind of shut off my Java roots and start to, get more used to Go. But I like it a lot now. Fortunately, since I work on it.
Maybe one thing that surprised me was just the value of having a really good and strong community. Before working on Go, I'd only worked on really tiny open source projects, and they're like, having a good community is important, but carrying that out at scale is sort of another level of complexity that requires a lot of care and intent. And it was something that I hadn't really thought that much about coming into Go, was that you really need to tend to the community to make sure that it's a good and strong community. And the community, and when you do that, the community will give back. Like, it's incredibly, it's worth the time to do.
This is somewhat related, but yeah, I'd say the biggest surprise for me is not, it's not technical issues or bugs. The biggest surprise for me has been the adoption of Go. I mean, it seems sort of natural now that, Go is up there in the top 20 programming languages, or the top 15 maybe. But, I have to say that when I joined the project, when there were just 5 of us, it was sort of like, it was an experiment. It was going to be, let's try out these concepts in programming language design. Let's try to see if we can get other languages to pick these up. Let's try to see if we can, say, here's some things which languages haven't been paying attention to. Let's have other languages start paying attention to them by showing what we're able to do in this area. But then, it became a thing in itself. It wasn't. Became that it wasn't an experiment. It wasn't something that other people could get ideas from. It actually became, the thing that people actually used, and it just started, growing and growing and exploding, and it's still growing today. And there's, probably 1 million Go programmers out there, maybe more. That's been the biggest surprise for me. It's really been astonishing, and it's still astonishing that we can have a conference like this, distributed around the world. People are actually paying attention, and it's not a purely academic thing, but something that people are really using in their everyday work life, even in their everyday hobby life. It's pretty amazing.
I feel like I can echo that. It's crazy to me how a programming language can have such a community, right? I feel like the big languages I encounter on the other side, I do a lot of data engineering and machine learning in Python, and that community is not the same, right? Python was like basically maintained by one guy for so long, and it doesn't have that awesome community aspect. And Java was Sun Systems, baby, right? Like, it was a kind of, they didn't have a good community around it. It just was what they wanted it to be. And it's just crazy to me that you can have so many open source projects and meetups and conferences, and you get so much feedback, and that feedback's respected. Like, I never expected that when I started Go, and look at me now. I'm moderating a chat with the Go team. Like, it's just crazy to have that much community involvement in a programming language and in using the programming language. Natalie, I think you're muted again.
Is this okay now?
Yep, we're good. We're good.
Hey, my goodness. Obviously, this visible prefers US people. That's an objective fact, by now. What I found most surprising about Go is how versatile it is, I guess. When I graduated university, my dream job was NVIDIA. I really loved parallel programming, and I was like, yes, this is so interesting, but I moved to Berlin, and my first job said you have to learn Go, so that's how I came to the language. And I had no idea how long I'll stay. I thought maybe as long as I work in that company, but it's been since 2014. And with time, I found different focuses that are interesting for me. So the first 3 years I was focused on doing web stuff, and I used Go for what I see as a traditional aim of it. And then I started being interested in infrastructure, but I still stayed in Go because all the tooling is used in Go, and you can do so much with Go around the infrastructure that supports the web application. And then I started being interested in machine learning, and it's still, I don't even need to switch the language. So just staying in this ecosystem and doing so many different things for fun or for work is surprising and is awesome for me.
Okay, so just to close us off, do you guys have any final thoughts you want to put out there to the community? Words of warning, begs for help, or just encouragement from the people that do all the black magic behind the scenes?
Well, I'd certainly like to thank both of you, Miriah and Natalie, for hosting this and moderating it and making it run smoothly. Thanks very much, and thanks to GoLab for providing us this venue, and I hope people find it useful and interesting.
Absolutely, I can echo that. It's nice to talk to some people across the globe, and even members of my own team that I haven't really talked to over the last couple of months, to kind of see what's going on with them during this kind of difficult time. So yeah, thanks so much for having us on, and for all the really thoughtful questions that were brought up.
Yes, thank you. And thank you to the whole community. Keep being awesome.
Hey
Sounds
guys,
great.
mind if I pop in?
Please come join us. This is
Hi.
the last activity for today, right?
Yeah, it should be. I just wanted to say, on the behalf of all of us here at GoLab, on the behalf of Develer too, all of us, we're all infinitely grateful that you all could join us in GoLab this year. It was really priceless to have you all share your experiences from all different aspects with the other Gophers. So, especially considering the time zone difference, some of you are just waking up, and we really appreciate that. Even if it means you didn't get to come to Florence this year, at least you can do it in your pajamas. It's always a good thing. So I wanted to say I hope you all are, able to come to the next edition. Let's have our fingers crossed that it'll be in person. We'll see. Time will tell. And yes, thank you again so much for your time and for your experience and insight.
Thank you.
Thank you.
Thank you.
Thanks.
All right, fantastic. Well, we'll see you all around. Thanks.
I'll see everyone tomorrow.
Yes, I was just about to announce all of the things happening tomorrow. So we're starting off with a 3-hour workshop on design patterns for production-grade Go services. And then we'll have accelerating developer velocity, building an API management platform in Go. And then, of course, yes, Miriah will be here with data engineering in the #Go shop. And then we'll have finally Clips in Go, an expert system shell for Go. So for those of you who are joining us tomorrow, thank you. If not, then I hope you've enjoyed this very much, and we'll see you around. Thanks for coming. Bye-bye.